Hello students, let us start with sixth part of chapter 13. Stereoisomerism. You have studied a little bit in the last video about stereoisomerism. Here we are studying stereoisomerism for a particular example of ethane, which is given in NCERT, specially single example. Now, what is stereoisomerism? Isomers which have the same structure formula but have different relative arrangement of atoms or groups in space are called stereoisomers, and phenomena is called stereoisomerism. Since each different spatial arrangement of atoms which characterizes a particular stereoisomer is called its configuration. Therefore, stereoisomers have the same molecular structure but different configuration. Now, types of stereoisomerism. Number 1, conformational isomerism. Number 2, optical isomerism. Number 3, geometrical isomerism. Start with conformations. Two-dimensional or 2D representations of conformations. Now, three-dimensional structures can be represented on two-dimensional space, like on the sheet, on the paper of your notebook, with the help of Fisher projections. The conformation of a molecule are usually represented by the following two methods. Number 1, Sahor's formula. Number 2, Newman formula. Let us start with Sahor's formula. The molecule is viewed slightly from above and from the right and projected on the paper. The bond between the two carbon atoms is drawn diagonally and is slightly seen for clarity. The lower left hand carbon is considered to be toward the front and the upper right hand carbon towards the back. It's shown on the screen, that is, one is eclipsed and other is staggered. In case of staggered, I give you a trick. As the staggered, S means stable, S. Staggered is more stable. Why? You can see on the screen the two hydrogen atom at the top are quite away from the two hydrogen atoms at the bottom. Means there is lot of distance between them. If there is lot of distance between them, there is less repulsion. If there is less repulsion, it means they are more stable. And when you just have a glimpse of eclipsed structure, in that case, just see on the single hydrogen which is at the top. It is very much close to the single hydrogen which is at the bottom. Means their distance is less, so repulsion is more, so stability is less. Now, Newman projection formula. These projection formula are obtained by viewing the molecule along the bond joining the two carbon atom. The carbon atom near the eye is represented by a point. That point is at the center of the big circle. There is the big circle on the screen and there is the point where the three lines they meet. The carbon atom near the eye is represented by a point and the three atoms or groups attached to it by three equally spaced radii. The carbon atom farther from the eye is designated by a circle and the three atoms or groups attached to it three equally spaced radial extensions. Dear student, just see the staggered structure on the screen. There is a big circle. That big circle represents the carbon atom which is away from our eye, which is away from my eye. Okay, your eye. and the center of three lines, that single dot, that dot means the carbon atom which is near to my eye. Okay. Now, relative stability of staggered and eclipsed conformation of ethane. In staggered conformation, each of the hydrogen atom on the front carbon lies exactly in between each of the hydrogen atoms on the back carbon. In other words, in this conformation, any two hydrogen atoms on adjacent carbon atoms are as far apart as possible. As a result, the repulsions between the electron clouds of sigma bonds of two non-bonding hydrogen atoms is minimum. On the other hand, in eclipsed conformation, each of hydrogen atom on the back carbon lies exactly behind each of the hydrogen atoms on the front carbon. The non-bonding hydrogen atoms are quite close. As a result, the electron clouds of sigma bonds of two non-bonded hydrogen atoms repel each other. This raises the energy of eclipsed conformation relative to staggered conformation. This repulsive interaction between the electron clouds which affects the stability of a conformation is called torsional strain. Here is one definition of torsional strain also. The magnitude of the torsional strain, however, depend upon the angle of rotation about carbon single bond carbon. This angle is also called dihedral angle. So, two definitions, one definition of torsional strain, other definition of dihedral angle or torsional angle. Of all the conformations of ethane, staggered conformation has the minimum torsional strain and the eclipsed form the maximum torsional strain. The same thing I told in the last slide. The staggered conformation of ethane is about 12 to 55 kJ per mole, more stable than the eclipsed conformation. Thus, it may be inferred that rotation about carbon single bond carbon is not completely free. This energy difference of 12 to 55 kJ per mole between the staggered and eclipsed conformation is in fact the energy barrier to rotation about the carbon single bond carbon in ethane. However, this energy barrier is not large enough to prevent rotation. Thus, the two conformations are readily interconvertible. As a result, it is not possible to separate the two conformations of ethane. However, at any given moment, most of the ethane molecules would exist in the staggered conformation due to its minimum energy and maximum stability.